I didn't record the other day. All right, so again, if A is greater than 0, my graph is going to open up and we have a minimum value. If A is less than 0, my graph is going to open what? Down, and we're going to have a maximum value. What's a y-intercept? What's a y-intercept? What is a y-intercept? A y-intercept, yeah. It's where it crosses the y-axis, okay? And which one's the y-axis again? It's the vertical one. And what is the x-coordinate of a y-intercept? 0, right? So let me ask you, if I put 0 in for x, what would I be left with here? What's 0 times anything? 0. What's 0 times anything? 0. And what's 0 plus a constant? It's the constant. So our y-intercept will always be whatever that constant is. So if you notice when we had that vertex, if I didn't have a bx, my vertex was at 0, comma, that c, right? Because it shifted it up or down, okay? The x-coordinate of my vertex, okay? To find the x-coordinate of my vertex is actually negative b over 2a. We have to actually do a calculation now, okay? It is found by taking negative b over 2a because that b shifts my graph left or right a little bit. So we have to use negative b over 2a, okay? The vertex, okay? The vertex, we know the x-coordinate of my vertex is this negative b over 2a. How do you think you're going to find a y-coordinate if you know the x-coordinate? If I give you a problem such as, say, y equals 2x squared plus 5x plus 3, and I say x equals 10, random problem, but x equals 10. If I know what x is, how would I find the y? Plug the x in, right? So to find my y-coordinate, you plug in x, and find y. So can you guys do orders of operation? Yeah. Do you have calculators too to help? Yeah, but you don't need them, but yes, you do, okay? And then again, what do we know about our axis of symmetry? It's always x equals what? So is x equals the x-coordinate of my vertex, right? What's my x-coordinate of the vertex? What's the x-coordinate of my vertex? Negative b over 2a. Negative b over 2a. I'm getting ahead of myself. Negative b over 2a. Make sure you guys are writing these down because these are formulas. So you're going to have to use them when it comes to your test or quiz. Okay? All right. Find the axis of symmetry and the vertex of this graph. Okay? The axis of symmetry, because we have a b, we have a bx, right? What is my a in this problem? My a is 2. My b is what? 8. And my c is negative 1. As soon as I have a b, I have to use my formula. Okay? So again, to find the axis of symmetry, it is x equals negative b over 2a. So I always put what I'm going to plug in parentheses. Okay? So negative b. What is my b in this problem? 8 over 2 times a. And what is my a? 2. So we get a negative 8 stays a negative 8. What's 2 times 2? 4. And what's negative 8 divided by 4? Negative 2. So my axis of symmetry is just x equals, what'd you guys figure out? It's negative 2. So this is my axis of symmetry, x equals negative 2. So is that too bad? Now, my vertex. Guys, you already know the x-coordinate of my vertex because doesn't the axis of symmetry go through my vertex? So what is the x-coordinate of my vertex? -2. The x-coordinate, because it says x equals 2, that's your x-coordinate of your vertex. How do I find my y-coordinate? How do I find my y? We plug it in, right? We plug it in. So what's my equation? F of x. Doesn't that just mean y? So y equals 2 times x squared plus 8 times x minus 1. What is my x? What's replacing the x? -2. And then do we know how to follow orders of operation? Can you use your calculator? Yeah. Make sure, guys, if you're putting -2 in a calculator to square it, does that -2 have to be in parentheses? Yes. -2 squared with and without parentheses are different, remember? Okay. But we should always know -2 squared is what? A negative times a negative is always a positive. So what is -2 squared? 4. And what's 2 times 4? 8. Plus, what is 8 times -2? -16. And then we have -1. And what's 8 plus -16? -8. And -8 minus 1 is -9. So this here is my y-coordinate. So my vertex is going to be -2, comma, what do we get for y? -9. And that is your vertex. So let me ask you, how does this transform? Okay, let's do our transformation. It doesn't ask, but I'm just kind of adding into this. Which way does my graph open? Because my A was 2. This opens up. Okay, so do we have a reflection? No. Okay. A is 2. Do we have a vertical stretch or vertical shrink? Stretch. So we have a vertical stretch. Stretch, if I can spell it right. Okay. And then now our vertex is not 0, 0, right? So how does this graph look? To worry about our left, right, up, downs, anything like that. Okay. How do I graph -2, 9? If I go to graph that point, how do I graph that point? -2, -9. Chloe? We go left 2 units and down 9 units. So there's your transformation. Okay. Now, obviously, don't ask that your mom is going to ask that part for you, okay? All right, let's go ahead and let's do 2 together, and then I'll have you guys do 1 on your own. Okay. All right. So we're going to do the same thing we just did here, okay? Now, in this problem, f of x, again, just means our y. So y equals 3x squared minus 2x. Okay. And again, it's from the form of y equals ax squared plus bx plus c, right? So what is my a in this problem? 3. What's my b? -2. And what's my c? 0. Okay. So in this case, okay, because we have a b, we know we have to use our formula, right? So let's find our axis of symmetry first. And how do we find the axis of symmetry? X equals -b over 2a. So -b over 2 times a. So what is replacing my b? -2. Don't lose negatives, right? And what's my a? 3. So a negative and a negative make a positive. 2 times 3 is 6. And what does 2 over 6 simplify to? 1 over 3. Okay. So we know my axis of symmetry is x equals what? 1 over 3. Okay. So you guys know your vertex. Now we know, or our axis symmetry. We know one of our coordinates of my vertex. What's the x coordinate of my vertex? 1/3. How do we find the y coordinate? How do we find the y coordinate? Just plug it in. Yeah. So y equals 3 times x squared minus 2 times x. And what is replacing my x here? 1/3, right? Now, do you guys have calculators? Yeah, you guys can use your calculators, right? Okay, so let me ask you, what's 1/3 squared? What's 1/3 times 1/3? No, what's 1 times 1? 1, and what's 3 times 3? 9. So 3 times 1/9 is, okay, let me put 3/1. Can I cross simplify? Yeah, that would be a 1, and this would be a 3. So don't I get 1/3 back? Can't see? I can see it. Okay, 1/3, right? If I cross simplify, minus 2 is the same thing as 2/1, right? Can I cross simplify that one? No. So 2 times 1 is 2, and 1 times 3 is 3. Hey guys, this is kind of nice because isn't that common denominators? So what's 1 minus 2? -1, and we leave our denominator the. So what is the y coordinate? -1/3. All right. Now it does not ask, but let's do our transformations. Which way does this open? Up, right? So do we have a reflection? No. Okay. Do we have a vertical stretch or vertical shrink? Vertical shrink because we're multiplying by 1/3. And then how do I graph 1/3 -1/3? How would I graph the point 1/3 -1/3? Okay. Would I go left or right? I'd go right 1/3. And then -1/3, would I go up or down? I would go down 1/3. So there's your transformation. Okay. All right. Now, number 1 here, I'm going to have you do it on your own, but let's do our A, B, and C real quick. What's my A? 1. What's my B? 6. And what's my C? Okay. All right, go ahead and find your X. Actually, just find your axis of symmetry first. I'll give you a minute to find your axis of symmetry because I don't want you, if your axis is wrong, won't your vertex be wrong? Yes. So I'll give you a second to do that. Okay. So what did you guys remember? It's -B. So what's my B? 6 over 2 times A. And what's my A? 1. So -6 stays a -6. And what's 2 times 1? 2. And -6 divided by 2 is? -3. So my axis of symmetry is what? X equals -3. You need to have the X equals, guys. Now, for your vertex, what's your X coordinate? -3. Now, go ahead and find my Y coordinate now. And how do we find our Y coordinate? Plug it in. So So go ahead and plug it in. So I equals x squared plus 6 times x plus 5. And we're plugging in -3. Make sure you use parentheses if you're using a calculator, right? No, if your calculator gives you square something and gives you negative, you probably did something wrong, right? Okay. Remember, calculators do what you type in. Okay, so make sure you type it in correctly. So if I were you, if you don't want to forget the parentheses, if you type in -3 squared, I would just do 3 squared, because -3 squared and +3 squared, isn't that the same thing? Yes. Okay. So what did you guys get? -3 squared is 9. What's 6 times -3? -18 plus 5. 9 plus -18? -9, and -9 plus 5? -4. Ooh, -4. So my y coordinate is -4. So let's talk about our transformations. Does this graph open up or down? It opens up. Why? Because A is positive, right? Now, if I multiply by 1, does anything change? No. So we don't have a reflection. Do we have a vertical stretch or vertical shrink? No, because when I multiply by 1, my number doesn't change, does it? It doesn't get bigger. It doesn't get smaller. Okay, it's equal to 1. Now, how do I graph the vertex? How do I graph -3, -4? I go left 3 and down 4. So the only transformations here is the vertex, instead of 0, 0, shifted left 3 and up or down 4. Sorry, up 4, down 4. Okay. All right, any questions? So out of your homework tonight, just so you guys know, your first 6 problems, or actually 4 problems, is doing what we did here, where you tell me the axis symmetry, tell me the vertex, and then tell me the transformation. You have 2 just finding the vertex and axis of symmetry. That's it. Okay. Now, the next part, the last 4 questions, is actually graphing it. Okay. So I'm going to change the directions a little bit with this. But first, can you find the axis of symmetry? You know how to find the axis of symmetry? And how do we find the axis of symmetry? X equals -b over 2a. Okay. Then, once you know the axis of symmetry, can you find your vertex? Yeah, because our x coordinate is my -b over 2a. And how do you find the y? Plug it in, right? Okay. And then from that, I'm going to use a table of values to get 2 more points. And I always do it around the vertex. Okay, around the vertex. So we won't always use 1, 2, -1, -2 now, because my vertex isn't 0, 0 anymore, is it? No. Okay. All right, so let's look at this problem. Okay, so 3x squared to y equals 3x squared minus 6x plus 5. Which way is my graph going to open? Up. So if you don't graph it, your graph up, you did something wrong, right? Okay. What's my A here? 3. What's my B? 6. And what's my C? 5. Okay. So once again, we know it opens up. Is this a vertical stretch or vertical shrink? Stretch. So it's going to be more narrow, right? So our numbers are going to be spaced out a little bit more. Okay. Now, go ahead and I want you guys to find the axis of symmetry and stop. So x equals. So find my axis of symmetry first for me. And then stop before you do your vertex. So I want to make sure we get this part right. Okay. what did you guys plug in for your B? -6, and my A was 3. 2 negatives make a positive. 2 times 3, 6, and 6 over 6 is 1. So x equals 1 is my axis of symmetry. So just so you guys know, if I draw a vertical line at x equals 1, my vertex should fall on that line, right? That's what it's going to be symmetric around, okay? So what is the vertex? What's my x coordinate of my vertex? 1. Can you guys find your y coordinate? Yes, and how do we find the y coordinate? Plug it in. So I'll go ahead and plug it in for you, and then I want you guys to get the answer. So 3 times 1 squared minus 6 times 1 plus 5. Plug in your 1 here and get me an answer. So make sure you follow your orders of operation, right? You don't have calculator. I do have some up here. I see you're using your phone for your calculator. That's fine for now. Just no testing quizzes you can't. So make sure you guys start bringing calculators, okay? So 1 squared is 1. 1 times 3. 3. Minus 6 times 1, 6 plus 5. So what's 3 minus 6? -3, and -3 plus 5 is 2. So my vertex is 1, comma 2. So I'm going to go right 1, up 2. All right, so now when I go to make a table, okay, and I actually drew the tables on for you. My vertex is going to be in the center of my table, right? So we know it's 1, comma 2. So before, we always picked values around my vertex. So if my vertex is 1, 2, what numbers are around 1? 2 and 3. Backwards would be 0 and -1. You guys okay with that? And because my vertex is where it's symmetric, the axis of symmetry, whatever I get for 0 and 2, they should have the same y value, right? And for -1 and 3, shouldn't they have the same y value? Yeah. So when I go to plug in to find my y coordinate, I could do 0 or I could do 2. Which one would be easier to plug in? The 0. So I probably would plug in the 0. So 3 times 0 squared minus 6 times 0 plus 5. This one should be easy for you guys, right? What's 0 times anything? 0. What's 0 times anything? And 0 plus 5? So these both values are going to be 5s. I always, if you have 0 on your graph or table, always use 0 every time. Okay, so could I graph 0, 5 and 2, 5? And do you guys see how it got more narrow? And then do you guys want to plug in -1 or 3? Your choice, -1 or 3. 3? Okay. And I'm going to use kind of a couple more spaces if that's okay. 3 times 3 squared minus 6 times 3 plus 5. If you use -1, that's fine. Go ahead and use -1 if you wanted to. And tell me if we get the same answer. We should. What's 3 squared? 9. And what's 9 times 3? 27. Minus, what's 6 times 3? 18 plus 5. What's 27 minus 18? 9. And 9 plus 5? 14. So both of these should be 14. Now, obviously, that's way off my graph, so I'm not going to draw it. There you go. There's your graph. What do you guys think of this? Not too bad. It's a lot of orders of operation, isn't it? Knowing, following your PEMDAS, right? All right, let's do this one here. Right. What's my A? 1. What's my B? And what's my C? Is this going to open up or down? Up. Okay, it's gonna open up. Do we have a vertical stretch or vertical shrink if we were multiplying by 1? If I multiply by 1, does my numbers get bigger, smaller, or stay the same? Stay the same. So we don't have a vertical stretch or vertical shrink. So the width of my parabola is going to be the same as my parent function. But we do know it's going to transform left or right, right? Because we have a b. Okay. So in this case, find my axis of symmetry for me. X equals negative b over 2 times a. Go ahead and find my axis of symmetry. Roland, you just got here. I'll just be really lost. All right. So what's my b here? But what's my b? Negative 8. And what's my a? A negative and a negative make a positive. 2 times 1. And 8 divided by 2. 4. So my axis symmetry is x equals 4. So I know my vertex is going to land on this line. So what is the x coordinate of my vertex? 4. Can you guys find your y? Yeah, go ahead and find my y for me. How do we find the y? We just plug it in. Four squared is 16 minus 8 times 4, 32 plus 7. What's 16 minus 32? Negative 16. And negative 16 plus 7? Negative 9. Wow. So my vertex is way down here, isn't it? 4, 7, 8, 9, down here. Good with that? Obviously, I didn't give a good graph. Okay. And now, can we make our table? Yeah. Where does my vertex go? And again, I drew these for you guys, so you don't have to worry about that. Where's my vertex go? In the middle. So we have 4, negative 9. So now you get to pick numbers around the 4. So what is around 4? 5 and 6. Going backwards, 3 and 2. Okay. So that should be numbers in row here. So 3 and 5 are going to have the same y, and 2 and 6 will have the same y. So my question to you guys, do you want to plug in the 3 or the 5? I'd do the 3. Why do you think I chose 3? It's smaller. I'd probably do 2 and 3. Okay. So I'm going to do 2 first, just because it's on the high. And then if I need more room, I can do. So 2 squared minus 8 times 2 plus 7. 2 squared. 4. 8 times 2? 16 plus 7. What's 4 minus 16? Negative 12. And negative 12 plus 7? Negative 5. So we know 2 is negative 5. So what else will be negative 5? The 6. So can I graph 2, negative 5? 2, negative 5? 6, negative 5? And then can I go ahead and do the 3 now? Yeah. So we're going to do 3 squared minus 8 times 3 plus 7. And I'm just kind of using my lines because we're not plugging in actually all of those numbers, am I? No. What's 3 squared? 9 minus 8 times 3? 4. What's 9 minus 24? Plus 7? Negative 8. These are both negative 8. So can I graph those? They're pretty close. And then here's your problem. Okay. So obviously we said there's no vertical stretch, no vertical shrink, there's no reflection, right? But it did, my vertex did move. And how did it move? How do I graph 4, -9? Right 4 and down 9. Okay. Any questions so far? Okay. Finding max and min values. Okay. Now, guys, you already know how to do this. Okay. We know what a max and min is, right? We know we have a maximum point. We know we have a minimum point, right? The actual values, so if it says find the actual minimum and maximum value, that is just the y coordinate of your vertex. Do you guys know how to find the y coordinate of a vertex? Yeah, that's your max and min value. Do we know when it's a max or a min? Yeah, okay. So the y coordinate of the vertex is the blank of the function when a is less than 0. When a is less than 0, does my graph open up or open down? A is less than 0, so what numbers are less than 0? Negative. So if a is negative, does it open up or down? It opens down, right? So would my vertex be a maximum or a minimum? It'd be a maximum. So you will have a maximum value when a is negative, when it opens down, okay? If a is greater than 0, that means a is positive. We know it opens up, so we will have a minimum value. Pretty easy. So let me ask you, can you guys find your vertex? And then can you tell me the y coordinate? That's going to be your max or min. You just have to tell me, is it a max or min? That's all, okay? So determine whether the function of this has a minimum value or a maximum value. Then find the answer, okay, value. So let me look at this. What is my a in this problem? -4. My b is 24, and my c is, all right, so our a, does this open up or open down? It opens down. So do we have a maximum or minimum? We have a maximum. So we're going to have a maximum value. Why? Because it says justify. Because it opens down. Right? So it's a reflection, right? Our transformation, it's a reflection. Now, can we go ahead and find our vertex? Yep. So to find our vertex, don't I need to find the axis of symmetry first? Yep. And how do we find the axis of symmetry? X equals -b over 2 times a. What's my b? 24. What's my a? -4. A negative and a negative make a positive. And 2 times -4 is 8. And what's 24 divided by -8? -3. So we know our axis of symmetry is x equals -3, right? So what's my vertex? What's the x coordinate of my vertex? -3. How do I find the y coordinate? Plug it in, right? So -4 times x squared minus 24 times x minus 19. And what is my x? -3. What's -3 squared or 3 squared? 9. And what is -4 times -4 times a +9? -36. We have minus, what's 24 times -3, or two negatives will make a positive, so I'm going to put plus sign. And what's 24 times 3? 72 minus 19. What's -36 plus 72? -36 plus 72? 36. And 36 minus 19? 17. So we know our y is 17. So guess what? You know your max value now. My actual max value is what? What is the y coordinate of my vertex? 17. That's it. Okay, the max value is that y coordinate. Does that make sense to you guys? All right, now let's put it into a story problem. So can we apply this? A firework is launched. Its height represented by function h of t equals -16t squared plus 128t. Think of a firework. It goes up and then it comes down, right? But how does it actually go up? Does it go directly up or does it go kind of at an angle? Usually, even if it's one of those mortars, it kind of falls over when it's because of the power, right? So really, technically, it kind of goes up, it hits its max, and then it starts to go down. It is actually a parabola, right? Yeah, okay, because it goes up. Same thing with if you shoot a basketball. Isn't that a parabola? Hit a baseball or softball, 9 times out of 10, it might be kind of flat unless you go directly to the ground. You're doing a parabola, right? It goes up, and then it has to come back down here. So if we're looking at this, do we have a maximum or value? Minimum. We have a maximum. We have a maximum height. So we have a maximum point, which is maximum value, which in this case is the maximum height that your firework will actually hit, right? And how did I know, besides knowing what a firework does, how else would I know that this parabola opens downwards? Isn't my A negative? Yeah, my A is negative. So in this case, what's my A? -16. What's my B? 128. What's my C? 0. Could you guys find your axis of symmetry? Could you find your vertex? And once you know your vertex, do you know your maximum height? Yes, because my maximum height is always the y coordinate of your vertex. Do we do that? Yeah. Do we need to keep going through that, or do you guys feel confident with this? I feel like we've done a lot of plugging it in, doing your calculators, that kind of stuff. Okay. Any questions with this?